Hello everyone and welcome to the webinar. This webinar is based on working with Play framework. This webinar is presented by a group of software consultants from Noldas. This group is having Abhinav Sharma, Chitra Sapkal, Purva Agarwal and me, Divyansh Devrani. A little bit about Noldas. So Noldas is a team of passionate technologists with a product mindset who work along with the business to deliver solution at a speed of competitive advantage. Our main capabilities are microservices and API, IoT, data science, data engineering and DevOps. We also have our strategic partnership with Lightband, Databricks, IBM and many more to deliver more values to the client. So let's start with our agenda. So we will talk about introduction to Play framework, followed by features. Then we will see what is the architecture of Play framework, then anatomy of Play framework. Then we will go to models, views and controller, followed by HTTP routing, and then we will have a demo about how we can make API on Play framework. Introduction to Play framework. Play is an open source web application framework which follows MVC architecture, or which is also known as Model View Controller architecture. Play is written in both Scala and Java languages and can be compiled on JVM. Play is a high productivity Java and Scala web application framework. It is a full stack framework with simple, flexible and powerful HTTP. Play is based on lightweight, stateless, web-friendly architecture and feature predictable and minimum resource consumption for high scalable application because of its reactive model and because it is based on Akka streams. Let's talk about features of Play framework. Play is a full-stack web framework. It means it can be used to make backend as well as frontend of a web application. Play is asynchronous, which means that in Play, the occurrence of an event is independent of the main program flow. Play is based on Akka, which means it can be used to construct concurrent and distributed application on JVM. Play is stateless, which means that every HTTP request happens in complete isolation. When the client makes an HTTP request, it includes all the information necessary for the server to fulfill the request. The server never relies on the info from the previous request from the client. Play is a lightweight and scalable. It means it is fast and can increase and decrease its performance in response to the change in the application and system processing demand. Play can support HTML5. In the Play, JSON, which is also known as JavaScript object notation, is treated as the first-class citizen. Understanding the Play architecture. Play application follows MVC architecture pattern applied to web architecture. The pattern splits the application into separate layers. The first layer is presentation layer and the second layer is model layer. The presentation layer is further split into two parts, view and controller layer. We will talk about MVC further in this webinar. As you can see, the HTTP request is received in the framework. Then the router components try to find most specific route able to accept the request. The corresponding action method is then invoked. The application code is executed. If a complex view needs to be generated, a template file is rendered. The request of the action method, the HTTP response code is then written as then HTTP response. Anatomy of Play framework. The layout of Play application is standardized to keep things as simple as possible. After first successful compilation, the project structure look like this. Here we are having few directory like app directory, public directory, conf directory, lib directory as well as target directory. As you can see, the app directory contains all the executables, artifact, Java and Scala source code, template, compiled asset source. It also contains 3 packages, one for each MVC architectural pattern. The public directory resources stored in the public directory. The static assets that are served directly by the web server. This directory is split into subdirectory for images, CSS and JavaScript file. The conf directory. So this directory contains the application configuration file like application.conf and route file. If a library needs a specific configuration file, it is a good to provide under the conf directory. The lib directory. It is an optional and contain unmerged library dependencies. That is all jar file you want to manually manage outside the build system. Just drop any jar file here and they will be added to your application class path. The build declaration are generally found in build.sbt. The project directory contain sbt, build definition like plugins.sbt and build properties. The target directory contains everything generated by the build system. The target folder have classes / file which have all the compiled classes, classes underscore merged / it contains classes which are managed by the framework, resources underscore managed / file which contains generated resources such as CoffeeScript compilation result and src underscore managed / it contains generated source such as Scala source generated by the template system.
Let's move to the another important part of the Play framework, which is the MVC, that is the models, views and the controllers. Let's start with the model first. So what is the model doing? Model is the domain specific representation of the information on which the application operates. It contains the data structure and the operations needed to operate an application. All the logics needed by the events happening on a browser are kept in the models. So basically, models add a meaning to the raw data by adding a defined logic in it. For example, calculating if today is user's birthday or calculation of a taxes, shipping charges for a shopping cart, etc. All these are the examples where actual logic is required, and the models are the object where we can define all this logic. Models can be used in two scenarios, either for adding a logics into events which I just discussed or for performing a database operations on data. Most of the time what happens is you will need to save a model object data permanently, and most natural way is to save this data into a database. So for doing such a database operation, models are helpful. Here we can see how models can be used in our code base. We have a program which calculates even numbers from the list of numbers and return a list of integer numbers divisible by 2. So in this scenario, if user want to save a even numbers list into a database, in that case by extending a model we can perform a store database operation. Next important component of Play is a view. Most of the application's view are generated using an efficient templating system provided by the Play. The views renders the model into a form suitable for interaction, and it typically used for the user interface. There is no necessity that only a single views can be used. Multiple views can also be exist for a single model with a different scenarios. The format of the views is usually available in the web format like HTML, XML or the JSON. There are some cases where user wants some dynamic changes to be displayed on their web browser. So in that case, binary format view can also be used. Here is the sample example for the HTML formatted view file and how it looks like. There are different HTML tags used to display different content for a web browser. Like title tag contain the title name and the section tag contain actual information for the same. So after getting data from the model layer, controller applies these templates, and once that templates applied, the data get displayed on the web browser. So basically views are just for a user perspective to display a user interface. This is how views are created in the Play framework. The last component of a Play framework is the controller. Controller is a Java class hosted by the controller package and the subclassing play.mbc.controller. Controller responds to actions and the processes them. So what exactly action mean? The action is a controller play an action control play an important role. Each public static method in a controller is called an action. The signature of an action method is always a public static void action name and the parameters that need to be specified. The snippet in the slide shows how controller and the action looks like. We have a class client which extend a controller. There are two actions specified in it, namely shows and delete, with one ID parameter in it. These parameters will automatically resolved by the framework from the corresponding HTTP parameters. One more feature Play controller provides, which is called as a default controller. This default controller is used to perform special actions, and this can be invoked directly from the route file. As name suggests, default controller is used in the case when after invocation of a route if user wants to redirect to some default or the fixed web page. In the below example, we can see that we have one get route with path/about, and we are invoking a redirect method of a default controller with the help of an input string of a fixed name of that web page. Here in the snippet, we have that redirect fixed URL name www.playframework.com. So what it will do is get/about route redirects to an external website. Similarly, we have a not found error to do are the members of the default controller. Now let's summarize how controller models views work together in a flow with the help of a diagram. In the web application, events are typically referred as a HTTP request. So what it does is, once HTTP request triggered, controller listens for that HTTP request, extract the relevant data from the events such as the query string parameters, request header, etc. and applies the changes to the underlying model object. Once changes are updated from the model layer, controller applies the templates from the view to decorate the corresponding object, and the HTTP response gets generated, which can be seen in the form of a user interface. So in this way, controller views and models work together to create a particular web application in easiest way.
So after getting to know about controllers, let's move on to actions and results. Actions. Most of the requests received by a Play application are handled by an action. It processes the request and produces the result. An action returns a play.mbc.results value representing the HTTP response to send to the web client. It is basically a method that processes the request parameters and produces a result to be sent to the client. An action method written in Scala is seen as a function and must return a value. This value will be used by the framework to generate the HTTP response resulting from the request. It can of course return several kinds of values depending on the request, like for example an HTML, XML, JSON, 200 OK or a forbidden value. For an HTML type, the response content type will be automatically set to text/HTML. For an XML type, the response content type will be automatically set to text/XML. For a text type, it will generate a 200 OK response filled with the text content. The response content type will be automatically set to text/plain. For a JSON type, it will be automatically set to application/JSON. Some others are bad request, unauthorized, not found. In the example, we have a package controller. We have imported the required imports. We have created a class application. As we can see, we have created an action that returns an OK response. This is the simplest way to create an action. It returns a 200 OK response containing a text/plain response body. Moving on to the result. An HTTP result contains three main components: a status code, set of HTTP headers, and a body. Let's start with simple results. An HTTP method with a status code, it can be anything such as OK, bad request, not found, internal server error, as we have discussed in actions. A set of HTTP headers and a body to be sent to the web client. These results are defined by play.mvc.result, and the play.mvc.results class provides several headers to produce standard HTTP results, such as the OK method we have used in the previous example. Redirecting the browser to a new URL is just another kind of simple result. However, these result types don't have a response body. We can see in the example, it returns a status code 200 OK with a result of text type. This is an example which shows about controllers, actions, and results. We have a package controller. We have imported the required imports. We have created a class application that extends the control. As we can see, we have created an action that returns an OK response. The simplest use case for defining an action generator is a method with no parameters that returns an action value. Here, index method takes no parameters. This is the simplest way to create an action. It returns a 200 OK response. Moving on to HTTP routing. A router is a component that translates an incoming HTTP request into an action. An HTTP request is taken as an event by the MVC framework, which we have studied previously. This event contains two major pieces of information: the request path, which includes a query string, and the HTTP method. Routes are defined in the conf/routes file, which is compiled. This means that you will see route errors. Moving on to the route file syntax. Conf/routes is the configuration file used by the router. This file lists all of the routes needed by the application. Each route consists of an HTTP method and a URI pattern, both associated with a call to an action generator. The last element is the call definition. You can also add comments to the route file with a hash character. The HTTP method, it can be any of the valid methods supported by HTTP. We'll see about them in the upcoming slides. The URI pattern. The URI pattern defines the route's request path. Parts of the request path can be dynamic. Here in the example, we can see the HTTP method is of type post. The request path is register/Twitter. The last element is the call definition. The last part of the route definition is the call. This part must define a valid call to a method, returning a play.api.mvc.action value, which will typically be a controller action method. If the action method defines some parameters, all these parameter values will be searched for in the request URI, either extracted from the URI path itself or from a query string. Play supports the following parameter types: string, int, long, double, float, boolean, UUID, any val wrappers for other supported types. Now moving on to the HTTP methods. The HTTP methods can be any of the valid types supported by HTTP. Some of these are get, post, put, and delete. The get method. The get method is designed to request a specific resource. In essence, it literally gets the resource in question and is pretty limited to just that action. It requests should only retrieve data, leaving other methods to perform the other transformative actions. It retrieves data from a web server by specifying parameters in the URL, as we can see in the example listed below. The post method. The post method is used to send data to the server, for example, customer information, file upload, etc., using HTML forms. Post affects the related resources attached to a targeted resource. It allows an API to submit an attribute or entity to a given resource. In practice, this means the targeted resource receives a subordinate resource that is part of a larger collection. Moving on to the put method. It is used to request the server to store the included entity body at a location specified by the given URL. It is somewhat polar opposite of get. While get requests a specific resource, put places that resource in the remote directory. It replaces all current representations of the target resource with the uploaded content. Then is the delete method. It is used to request the server to delete a file at a location specified by the given URL. It is the most clear-cut method on this list because it does exactly what's on the tin. It deletes the targeted resource. The typical response for a deletion method is simply to reply with an OK status, either the resource was deleted or it was not.
Now let's go for the demo. So as you can see on the left hand side, this is the play project directory structure. So now we can see inside inside the app package there are models, views and controllers package. So inside conf directory there is application.conf file and routes file. Basically application.conf file consists all the configurations of the project, where we can set database configurations and other project related configurations, and the routes file consists all the routes of the project, like we can define get, put, post, delete methods out on this file. So if you can see the routes file, in this file we can see there are two get routes here, ping route and fetch employee details route. So this is the syntax that how you can define the routes, and this is the way to take parameters in the URL. Here you define the data types of the parameter. So this is the way you can like take parameters in the URL, and here you are showing the data type of the parameter. Now after that, inside the controller package there is an application class in which we define or implement the routes functionality. So this is the you can see here, this is the ping method of the ping route which returns pong, and this is the employee details method of the employee details route which will return the employee details by the employee ID in the form of the HTML template. So this is the get employee details by employee ID method. Now inside the models package, inside the model package there is an employee details class. Basically model package consists all the logical operations or any database related operations classes. So if you want to perform any logic or database operation, you can put that inside the model package. So as you can see in this class, we add the logic to fetch the employee details by the employee ID. So you can see here with 101 ID we are getting these details in the form of the HTML template, and with 102 ID you are getting these details in the same HTML template. So with any other ID except these above two IDs, you are getting the error detail case class which returning the 400 response not found. So now let's see the view directory. So in views directory we put all the templates file related to the project like HTML and XML files. So this is an employee details template. So here you can see we are printing the name and the address of the employee. So here you are seeing this is the name and address of the employee, and this template we are using here inside the model class in that method. You can see here, and this method is calling, you can see this method is calling inside the application class of the controller package. So and this route will return the, this method will return the employee details of the users, of the employees. Now you can see here there is an build.spt file. So basically inside build.spt we put all the dependencies of the project. Like here I have enabled the scalable dependency. So let me show you the here. So you can see in plugins.sbt we have added the SBT plugin of the play, and we have enabled this plugin in our build.sbt file, and also we have added some other dependencies which are used or needed in the project. Now let's run our project. So let's run our project to see the demo, how the routes are working and how the play framework will work. So here, to run the SBT project, you have to use the command sbt run. So here I'm running the project. So first of all, the project will build first, and you have also play project, you all know that play project always run on the 9000 port. So here you are seeing that our HTTP server listening on the port 9000. So we have to hit the URL on the 9000 port. So this is the localhost, we are running on the localhost machine, and we have the ping route. So now yes, we are getting the pong response, because here you can see in our routes, this is the ping route and this is the ping method inside the application class, which are returning pong in the OK response. So as you can see here, this is the message abstract controller class which we are extending in the application. So basically this class consists all the actions related and this type of the responses or results. That's why we are extending this message abstract controller classes. Now after that, we have to hit the other route of the fetching the employee details. So here you can see we are getting the employee details by hitting the 101 ID. Now if you, for example, if you put any invalid or any other ID which are not exist in the database, so here you are seeing we are getting the bad request, because here we are passing the string and our code is accepting the int parameter. So here you can see the error also, cannot parse parameter ID as int for input string a. So to correct this or to solve this, we can do one thing. We can change the ID into the form of a string, and also here we will accept the string. In this method will also see the string parameter. This is going to solve our the passing this string parameter. So string can receive like int, also we can convert this string into any other data type. So it is good if we accept this string instead of accepting the integer value. So now let's run our project again and see if it's working or not. So application is started. Now let's try to hit the same route. File are compiling. Let's wait for 1 or 2 seconds. Yeah, so you can see the message, no employee exists from this ID, because there is no employee with this ID in our database. As you can see here, or in our code, there is no employee details here. So it is returning error detail 400, and if you are seeing any error detail method here, so we are sending the response not found, no employee exists from this ID. So that is the short demo for the play project. Now we move to the next slide. So this is the reference page. Here you can take the help from these sites or blogs. So so it will really helpful for you if you are going to start your project on the Play framework. Right, so thank you for attending this webinar. I hope you liked the session.